Welcome to today's class video. So in today's video we are going to do the calculations under perpendicular vectors and diagonal vectors. In our previous class we have been dealing on the theories behind all these vectors like parallel vectors, diagonal, perpendicular, and multi-parallel vectors. So in this video we are going to do the calculation of perpendicular vectors and diagonal vectors. And please, if you are preparing for any exams like jamb, post-UTME, WAEC, please please focus on this video, because these questions usually comes out from this aspect of vectors. Okay, now before then, the questions that I will be solving are majorly jamb questions as well as post-UTME and WAEC questions. So please stay focused to the end of this video, and as well as subscribe to this YouTube channel. Okay, now let's dive into question 1. The diagram above shows two vectors at right angle to each other. The value of the resultant vector is. Now, one thing I usually do if I want to answer or solve any question in any exam I'm writing, I will first of all identify the topic in which the question is coming from. Once I have identified the topic, then I will identify the subtopic. Now, if looking at the diagram, if you look at the diagram above, you know that the two vectors are usually perpendicular to each other. They're usually perpendicular like this. They're usually perpendicular to each other. This will tell you that they are what? Perpendicular vectors. Now, looking at the question, they say we should calculate for the magnitude. For the magnitude of the resultant vector, they say we should calculate for the resultant vector. Remember, under perpendicular vector, how can we calculate for their resultant? We can calculate for the resultant using Pythagoras theory, which is r square equals to a square plus b square. Now, we are looking for r, which is the resultant. The vector A is 6. Vector A is 6, then vector B is 8. So the square of before then, there are two different things. Square and square root are two different things. Look at square. For example, 5 square. This is square. Then square root like this. This is square root. Then why this is square? Okay, so 6 square is 36. Then 8 square is 64. Adding them together will give you 100. Therefore, r square is equals to 100. Now, we are not looking for r square, we are looking for just r. In order to cancel this square, we take the square root of both sides. This square will cancel the square root. We'll be left with r equals to square root of 100 is 10. So the answer is 10 Newton. So the answer to the question above is 10 Newton. Now remember, in one of our classes, I told you guys that in whatsoever question we are solving under vectors, the resultant is usually larger than the other vectors. Remember, vector A is 6, then vector B is an 8. Our resultant which we are looking for, the answer or the value of the resultant we are looking for must be longer than any of the vector. We cannot go and get answer that will be, let's say, 5, because it will not be correct. I don't know if you understand. Now, this can only be correct if it's parallel vectors. Anti-parallel vectors. Remember, under anti-parallel vectors, we subtract their resultants. Okay, so our resultant must always be larger than what? Any of the two vectors. So we'll move to question 2. Now, question 2. Two forces, 3 Newton and 4 Newton, act on a body in direction due north and east respectively. Calculate their resultant. Now, looking for the question, look at the nature of the question. They said that two forces, one of them is 3 Newton, the other one is 4 Newton. Two forces, 3 Newton and 4 Newton, act on a body in direction due north and due east, respectively. Looking at the diagram they form, these vectors, they are perpendicular to each other. Therefore, they should look for their resultant vector. Don't mind where I draw it to. They say you should look for the resultant vector. So these two vectors, they are perpendicular to each other. So this question is under perpendicular vector, and then so you can calculate for the resultant vector, which is so easy. How can you calculate for the resultant vector? We make use of Pythagoras theorem, just like the previous question we did. R square equals to a square plus b square. Now, because I'm using r square equals to a square plus b square, in some textbook it will be r square equals to p square plus q square. Is the same thing. Okay, so I just love using a and b. So r square equals to a square plus b square. Our a is 3, then our b is what? 4. Okay, the square of 3 is 9, then the square of 4 is 16. Okay, if you adding them will give us 25. Now, then in order to cancel this square, we take the square root of both sides. R equals to what? 5 Newton. Okay, now this is if you're looking at the resultant, the resultant is also larger than what? Any of the two vectors. If you solve and your resultant was 3 or 2, note that your answer is not correct. The resultant value must be always greater than any of the two vectors. Okay, now what if they ask us to calculate for the direction of the resultant? We know that the resultant is in direction northeast, Abi. Yes. Now, what if they say we calculate for the direction? We know the magnitude of the resultant as 5. Now, what about the direction? The direction is the resultant is pointing towards northeast, Abi. Yeah, but we don't know the direction. We don't know the angle. Now, if you go to our previous class under perpendicular vector, I told you guys that we can calculate for the magnitude of resultant vector making use of Pythagoras theorem. Then I said that we can calculate then the direct with this Pythagoras theorem. This is what we use to calculate for the magnitude of the resultant. Now, what about the direction of the resultant? How can we calculate for the direction of the resultant? We make use of tan theta equals to a over b. Now, remember that I told you guys in our previous class, theta talk about the direction or the angle in which the resultant face towards the horizontal. This angle is the one that tells us about the direction of the resultant. So this is the angle we are looking for. This angle stands for the direction of the resultant. Now, how can we calculate for the direction of the resultant? Make use of tan theta equals to a over b. Now, in order to make theta stand alone, we take the shift tan of both sides. If you want to look for shift tan, we take the shift tan. Yeah. Take shift tan, or simply we can say we divide both sides by tan. If we divide both sides by tan will cancel tan. Then this other side should now be, let's say, okay, now we divide tan. Now this 1 over tan is the same thing as shift tan. So if we divide both sides by tan, this tan will cancel here. Like divide tan, then divide tan. This divide tan is the same thing as shift tan. How can you do this in your calculator? Just press shift and you press shift in your calculator. Let's say this is your calculator. This is shift. Press shift, then you press tan. It will give you this. Okay. So theta will be equals to shift tan a over b. So our a is 5. Remember, our a is 3, then our b is what? 4. So theta equals to shift tan 3 over 4 we give us what? Shift tan 3 over 4 give us 37 degrees. So our resultant is at an angle of 37 degrees northeast. I don't know if you understand. So Yeah, this is how to look for the direction of the resultant. This is how to look for direction of the resultant. You can just say, to calculate for the direction of the resultant, it's just tan theta equals to A over B. Make it theta stand a little to B. Theta equals to A shift tan A over B. Okay, so we move to the third question. To our third question. Now, our third question, the magnitude of the resultant of mutually perpendicular forces F1 and F2 is 13. F1 and F2 is 13. So, they said the magnitude of the resultant of mutually perpendicular forces F1 and F2 is 13. They are telling that the resultant of two forces that are perpendicular to each other, of two forces F1 and F2 that are perpendicular to each other, they say the resultant of two forces F1 and F2 that are perpendicular to each other is what? Is 13. So the resultant of two forces that are perpendicular to each other is 13. That is what the question is talking about. So let's continue. If the magnitude of F1 is 5, then what is the magnitude of F2? So this question is so easy as well. This question is coming from perpendicular vector. How do I know that? Because in the question it was mentioned that the two forces F1 and F2 they are perpendicular to each other. So this is perpendicular vector. Okay, let's continue. So in this question, they gave us the resultant as 13, and they gave us the magnitude of one of the vector or of one of the force to be 5. Now we're looking for the magnitude of the other. We are looking for F2. We can just say, okay, F1 is A, then F2 is B. It's the same thing. So they gave us arrow to be 13. They gave us A to be 5. And we're looking for B, which is so easy. We make use of Pythagoras theory, which is arrow square equals to A square plus B square. Our arrow is 13. Then in this question, if we observe, we are looking for just B. In our previous question, we were looking for arrow. But now in this question, then we are looking for B. So our arrow is 13 square equals to A is 5 square. Then B, we are looking for B. So 13 square is 169. 5 square is 25. Then plus B square. Now, in order to make B stand alone, we take 25 to the other side. So 169, taking plus 25 to the other side of the equation, it's turned to minus. Remember, there's an invisible plus positive sign here. Okay, so 169, if this one come over, it will now be minus 25 equals to B square. Minus it then give you 144. Now, which is this thing is the same. Okay, this thing are the same thing. So now to make B stand alone, we take the square root of both sides. The square root cancel the square, so B equals to the square root of 144 is what? 12 Newton. So our arrow is 13, our A is 5, then our B is 12 Newton. If you look at it, the arrow is always larger than any of the two vectors. Okay, so move to the fourth question. Okay, now the more we are going, the more the questions become, tough, but it's so easy. Now, question 4. Two forces whose resultant is 100 Newton. Whose resultant is 100 Newton are at right angle to each other. You seeing right angle, you know that this question is coming out from perpendicular vector. Okay, they say two forces whose resultant is 100. Two forces, two forces. Now let's say this is force 1, then this is force 2. They said both of the forces are right angle to each other, and their resultant is 100 Newton. Look at the question. Two forces whose resultant is 100 Newton. The two forces they are they are triangle to each other, which can also be they are perpendicular to each other. Okay, if one of them makes an angle of 30 with the resultant, let's say this one now make an angle of 30. Let's say this first now make an angle of 30 degree with the resultant. This is the resultant. And this one make an angle with the resultant. The angle is 30 degree. Let's say, okay, let's continue. Determine its magnitude. That is, they say we should look for this one magnitude. Now let me break down the question. They say two forces, they are triangle to each other, or they are perpendicular to each other. Now the magnitude, the resultant of these two forces is 100. Is 100 Newton. Now they said one of these force. Okay, let's say this force is, force B or vector B, anyone. Remember, force is a vector quantity. So I can use vector in place of force. I can use force in place of vector, because based on the fact that force is a vector quantity. So let's continue. They said vector B, or let's say if one of the forces make an angle of 30, with the resultant, determine its magnitude. We are looking for the magnitude of this force, of this vector. Now this is quite tough, but it's so easy to solve. Now you guys have heard of SOHCAHTOA. You guys have heard of SOHCAHTOA. Now in this question, there are many ways we can solve for B. If you're looking at this question, they didn't give us A, they give us arrow, they give us angle. They didn't give us B, they should look for B. Unlike our previous question we have been doing ever since. Now, in this question, in order to solve this type of question, make use of SOHCAHTOA. Now, remember, in right angle triangle, remember that this long line is the hypotenuse. Then this one is the opposite, while this one is the adjacent line. This long one is the hypotenuse, this one is the opposite, while this one is the adjacent. H here stands for hypotenuse, O stands for opposite, A stands for adjacent. So now looking at this diagram and this part are the same thing. They are like this part is the same thing like this. That will tell you that our hypotenuse is our arrow, then our adjacent is our B. Then this A, this side now. Let's say this side and this side are the same thing, because if you draw the full square, they are the same thing. This side, remember, the first side of this, the first side of a square are the same, are equal. Okay, so this side and this side are the same thing. I can still call it A, but forget about the A. So remember, I told you guys that our H is our resultant, then our adjacent is our B. Now we are looking for B. Now out of these three mnemonics, out of these three, which one relates adjacent? Which one relates hypotenuse and adjacent together? Which one contains hypotenuse and adjacent together? It will be the second one. Remember, our arrow, or let's look at our arrow is this place. Our arrow is the same thing as the hypotenuse. Our B is the same thing as adjacent. So we take arrow to be hypotenuse, we take B to be adjacent. Looking at this three stuff, which of them have hypotenuse and adjacent together? It will be this second one. Car means cos theta equals to adjacent over hypotenuse. Now remember, our adjacent is our B, so B. The hypotenuse is the resultant, which is 100. Now theta, which is the angle, is what? 30 degree. Okay, cos 30. We are looking for what? B. If you cross multiply, to now be B equals to cos 30 times 100. Cos 30 is 0.866. Then times 100. Our answer will be equals to 86.6 Newton. So therefore B is equals to 86.6 Newton. Look, the question. Look, if you look at it, the question is so easy. So whenever you come across all this type of question, let's say look for the angle between the look for, like, if you come across any of this question, just know that I make use of so katwa. Now if you didn't understand the solving, you can write it in the comment section, or you can go through the video and like decrease the speed of the video in order for you to get the gist. Okay, so move to the next question. Okay, our next question. A ball is moving at 18 meters per second. A ball is moving at 18 meters per second in a direction inclined to the horizontal. This is the horizontal. This line is horizontal, this line is vertical. They said a ball is moving at 18 meters per second. Let's say it's moving in this direction at 18 meters per second in a direction inclined. A ball is moving at 18 meters per second in a direction inclined at 60 degrees to the horizontal. This is the horizontal. They said the ball is moving at 18 meters per second in a direction, in a direction inclined 60 degrees to the horizontal. They said what is they said, okay, let's continue. They said the horizontal component of its velocity is. Now, this question is similar to our previous question. They said we should look for vector B. Vector B is the horizontal. Remember, perpendicular vector. This is vertical. B, this is horizontal. A is vertical. B is horizontal. They said the horizontal component of its velocity is, like, you're looking for vector B. We're looking for vector B. Okay, so from our previous question, this is so similar to our previous question. This question is also talking about perpendicular vectors. It's also talking about perpendicular vectors. So this is the resultant. This is vector B. Then let's say I draw a line. This will be vector A. Okay, so this is the ball. The ball. This 18 stands for the resultant vector. This, we are looking for vector B. It's so easy using SOHCAHTOA. From our previous class, I told you guys that I drew a right angle triangle. I told you guys that the hypotenuse stands for the resultant, the adjacent stands for vector B, then the opposite stands for vector A. Okay, this side can also be vector A. They are the same thing. Okay, so in this question they gave us arrow to be 18, or we can say they gave us the hypotenuse to be 18. They gave us angle, they gave us theta to be 60 degrees. They said we should look for what? B, which is the adjacent. Now in this three stuff, which of them have hypotenuse and adjacent? It will be this second stuff. It will be the second one. This one means cos theta equals to adjacent over hypotenuse. This is similar to our previous question. Now theta is what? 60 degrees. 60. Then we are looking for adjacent, which is sent here as B. Then our hypotenuse is 18. Is 18. If you cross multiply, it will now be B equals to cos 60 times 18. Cos 60 is 30. Cos 60 is 0.5. Cos 60 is 0.5 times 18. Our answer will be 9. Newton, or 9 meter per seconds. You know why I put 9 meter per seconds? Because I'm making use of velocity here, so 9 meter per seconds. So our B is 9 meter per seconds. So yeah, this question is so easy. We move now. In our next question, we are going to solve on. We are going to this on question concerning diagonal vector. Now we are through with calculation on perpendicular vectors. Now we now move to calculation on diagonal vector. Okay, now let me bring the question under diagonal vector. Two vector have a magnitude of 3 Newton. Two vectors have a magnitude of 3 Newton and 5 Newton respectively. These two vectors, they act at an angle of 60 degrees towards each other. They act at an angle of 60 degrees towards each other. What is their resultant? We're looking for arrow. Now, some people, when they see this question, they will neglect the angle and they will make use of Pythagoras theory, arrow square equals to a square plus b square. But this question is not talking about perpendicular vector. Remember, perpendicular vector, they are always at what? Angle 90. That is, they are always perpendicular or at right angle to each other. Looking at this question, I said two vector have a magnitude of 3 Newton and 5 Newton respectively. These two vectors, they are at an angle. They are at an angle of, let's say, they are at an angle of 60 degrees towards each other. They are at an angle of 60 degrees towards each other. They are not perpendicular. Perpendicular is 90. Perpendicular is 90. They are at an angle of 60 degrees towards each other. So this question is talking about diagonal vector. This should look for their resultant vector. This should look for the resultants. The resultant can be something like this. I'm coming. The resultant can be something like this, or it can be something like this. The resultant can be something like this. The resultant can be something like this or like this. They are the same thing. Okay, just go back to our previous video on diagonal vector. You will know how to differentiate these two diagrams and all. Okay, so apart from that one, how can you know if we are going to solve? How can you know that the question is coming from diagonal vector and not perpendicular vector? How can you know? One, you can know in the sense that in any of your questions they will give you in diagonal vector, they will give you the two vectors together and they will give you an angle. They will look for the resultant. If it's parallel, they will not give you an angle at all. They will not give you an angle at all. They will give you the two vectors. They will say look for arrow. But if they give the two vectors, they give you an angle. They give you an angle. You know that they are talking about diagonal vectors. Or if in the question they didn't mention right angle or they didn't mention perpendicular and they didn't give an angle, you know that it's perpendicular vector. But here in this question they gave an angle. They gave the two vectors. They should look for arrow. So make use of cosine rule, which is easy. If you in our previous diagonal vector video, this plus and minus, I told you guys that it means this formula is two parts. Arrow square equals to a square plus b square plus 2ab cos theta, or arrow square equals to a square plus b square minus 2ab cos theta. I told you that is what this thing means. Just go to our previous video, you will see how I differentiate everything. So in this question, I'm making use of this positive sign. If you go to our previous video, you find out that why we are using the formula with positive sign. Okay, so our arrow square equals to a square plus b square plus 2ab cos theta. We are looking for arrow. A is what? 3. So 3 square. B is 5 square plus 2 times a is 3, b is 5. Cos our angle is 60. This one will be 9. This one will be 9. 3 square is 9. Then 5 square is 25. 5 square is 25. Then plus 2 times 3 times 25. plus 2 times 3 times 5, will be 30. Okay, will be 30. 2 times 3 is 15. 15, yeah, what am I saying? 2 times 3 is 6. 6 times 5 is 30. 30 cos 60 is 0.5. Cos 60 is 0.5. So 9 plus 25 is 34. Then 30 times 0.5 is 15. So 34 plus 15 will give us 49. So arrow square equals to 49. Therefore, arrow, now in order to cancel the square, take the square root of both sides. So arrow and square root of 49 is 7. So our resultant is 7. Our resultant is 7. So you find out that the questions on that diagonal vectors is easy.